2021, Paper 2, Question 1. In a particular population, 15% of the people are left-footed. A soccer team of 11 players, including a goalkeeper, is picked at random from the population. Find the probability that there is exactly one left-footed player on the team. Give your answer correct to 3 decimal places. We can do a simple Bernoulli trial here. So we can let P, the probability of being left-footed, be 0.15. Therefore Q, the probability of not being left-footed, is 0.85. N is 11, that's the number of trials or number of players, and R is the number of left-footed people we want, which is 1. Filling that into our binomial theorem gives us 0.325. Next we have to find the probability that less than 3 players in the team are left-footed. So we got to do less than 3 players, that means no players, 1 player, or 2 players. Given that I already know what P is, and what Q is, and what N is, I can do Bernoulli trials for each one of them, and I remember that OR means I'll add my results. So for 0 players, 11 trials, no successes, 0.15 to the power of 0, 0.85 to the power of 11. I already figured out the probability of 1 player, 0.325 in the first part of the question, and the second one, 11 players, choose 2, 0.15 to the power of 2 left players, and 0.85 to the power of 9. So putting those together will give us 0.78 correct to 2 decimal places. The goalkeeper is left-footed. Find the probability that at least 8 of the remainder of the team are right-footed. Give your answer correct to 2 decimal places. They're talking about the remaining players of the team, so they're talking about the 10 players that are left. So talking about the probability of 8 or 9 or 10, but be careful this time, right-footed players. So we have 10 trials. The number of successes is either 8 or 9 or 10. The probability of success this time is 0.85, which is the probability of a right-footed player. The probability of failure is 0.15. And in each case here, OR means add, so a Bernoulli trial for each. So we use a Bernoulli trial formula. We apply it for 8 successes, 9 successes, and 10 successes. We get a probability of 0.82.